So this video is all about derivatives, and we're going to be taking some derivatives of logarithmic functions, polynomials and trigonometric functions. So straight away onto the first one, we've got a function here 2x. So this is relatively easy to differentiate, but I'm going to break it up into simple terms so we can understand what's going on. So 2 to the 2x is basically 2x to the power of 1. So we're going to write it like this when we're using the power rule. We use a and b here. We can use any other letters you like, but I'm going to use a and b here because they're not very often used and it's easy for us to understand. So basically we've got a times x to the power of b. So in this polynomial here, we've got a is 2 and b is 1. So the first derivative is a times b times x to the power of b minus 1. So we reduce this power by 1 and then we multiply the power by the coefficient to get the first term of our derivative. So a times b times x to the power of b minus 1. So we'll have 2 times 1, which is our a and our b, times x to the power of 1 minus 1, which is 0. So that gives us then 2 times x to the power of 0. Well, x to the power of 0 is 1. So 2 times 1 is essentially 2. So therefore our first derivative of 2x is 2. Okay, so that's a nice easy one. So now let's try something now where we've got coefficients a little bit more and also the powers a little bit higher. So 2x squared. So we write 2x squared as 2 times x squared. So using our power rule formula, a times x to the b, where a is 2 and b is 2 in this case. So our first derivative will be a times b times x to the power of b minus 1. Always reducing that power by 1 when using the power rule. So we've got a times b, and the b is reduced by 1. That's basically what's going on here. So 2 times 2 times x to the power of 2 minus 1. So that gives us 4 times x to the power of 1, which is basically 4x. So hence the first derivative is 4x. That's a derivative there. So next one, let's bring some minus signs into it. So the next one we've got is minus 4 times x to the power of 6. Which we're going to write it like this, so it's easy to understand. Then we've got set it out in our power rule formula, so a times x to the b, where a is minus 4, that's a, and our b is 6. Okay, so for the first derivative we want a times b times x times b to the power of b minus 1. So this is reduced by 1, and we multiply this 6 by minus 4. So then we end up with minus 4 times 6, which is our a and our b values, and the 6 minus 1, which is 5. So we end up with minus 24 times x to the power of 5, which we write in the standard way, minus 24 times x to the power of 5. So that takes care of that one. And next time we've got one here, we've got one now with a negative exponent. So 3 times x to the power of minus 2. We could also call this 3 over x squared. But we're going to write it like this because it's the easier way to do a derivative. So our function is, again, break it down, 3x to the minus 2. 3 is the coefficient, minus 2 is the power. So a is 3, b is minus 2. So the first derivative, a times b times x to the power of b minus 1. So now remember we're reducing a negative term. So the absolute value of that increases. So minus 2 now goes to minus 3. So we've got 3 times minus 2, which is our coefficient and power. So that's that. And then the power is reduced by 1. So it's minus 2 minus 1, which is minus 3. So that then gives us minus 6 times x to the power of minus 3, which is written like that in a normal way. Or we could also write it as a fraction, minus 6 over x cubed. So that's the power function. So now we're going to have a look at some trigonometric functions, and we're going to use the chain rule in these. So the first one we're going to look at is sine of x. So our function is sine of 2x. Now we know that sine's derivative is cosine. So we're going to apply the power rule. So there's no power rule involved here because it's just sine, it's not sine squared, it's not 2x squared or anything like that. So straight on to the chain rule. So what we're going to do now, call g of x sine of x, and our input we'll call h of x. So g of x is sine of x, h of x is 2 of x. So there's our g of x, and inside the brackets is our h of x. Then we just find out the derivative of each of these g's and h functions. The derivative of g is cosine, so that's cosine of x. But our input is not x, it's 2x, so we have to take the derivative of 2x. So the derivative of 2x, which we worked out in the previous slide, was 2. So this now gives us our formula now to work out how we do it with the chain rule. So when you're doing the chain rule, the input, i.e. this part here, 2x, doesn't change, but you do have to multiply it by the derivative of what is inside. So therefore our derivative is h prime of x, which is the 2, times the derivative of g, which is cosine, which we worked out here, and h of x, which is the input, which doesn't change. So basically we've got h prime, which is cosine, which is 2, g prime, which is cosine, and the input is 2x. So just putting in these in one at a time, h prime is 2, because that replaces this one in here, just keep substituting the values, 2 times g prime h of x. The derivative of g prime is cosine, so it then becomes, without changing the input as well, we put the 2x in there as well, so 2 times g prime of 2x equals 2 times cosine of 2x. So the derivative of sine of 2x is 2 cosine 2x. So there we see, we say take the derivative of sine and then the derivative of the input and then multiply together and leave the input as 2x. Okay, let's try another one. So let's take the derivative this time of cosine squared of x. This time we have a power rule. So we're going to write this now cosine squared of x. We can write this also as cosine of x squared. So I've set it up like this so it's easy to read. So apply the power rule first. So set the function up as g of x to the power of b. There's no coefficient here, but you could have a 1 there if you wanted. You could have 1 times cosine of x to the squared, but no one ever writes that. So g of x is cosine of x, and then we set it up as b times g of x to the power of b minus 1. Now, which it gives us then 2 times cosine of x. That's where we are so far. So we're not going to take the derivative inside just yet. We're just going to apply the power rule for now. So the 2 goes to the front, and then the power reduces by 1. So that gives us 2 times cosine of x to the power of 1, which is 2 cosine of x. And now we apply the chain rule to the cosine. So this time the brackets involves the whole function inside. So it involves cosine. So we have to take the chain rule of, using the chain rule, we have to take the derivative of cosine, which we know to be minus sine. So g of x is cosine. The derivative of cosine we know is minus sine of x. So now we have to get to minus sine of x times what we got to when we applied the power rule, which is 2 cosine of x. So minus sine of x times 2 cosine of x is simply minus 2 sine of x cosine of x. That's the derivative there of cosine squared of x. So let's look at another one. This time we've got a coefficient, tangent, and a power. So we definitely need to apply the power rule first. So 3 tangent to the power of 4x. So we're going to write that as 3 tan to the 4x. And using the power rule as we've done previously, put the function in brackets and b is our power. Okay. So we've got g of x is tan of x. Then we do b minus 1. B times the g of x. Well, g of x is the tangent. So b times 3 tangent of x to the power of b minus 1. So b was 4, that's our power. So that b then substitutes for a 4, which have now gone undone here. So 3 times 4 is 12. So what we've got now, before we apply the chain rule, because we're going to need to apply the chain rule to inside the brackets, just with the power rule, we're up to 12 tan cubed of x. Now we apply the chain rule to the tangent. Now the derivative of tangent is secant squared of x. So if you look at my previous videos, you'll see why the derivative of tangent is secant squared. So it's basically 1 over cosine squared. So now what we have to do, we now multiply what we had after the power rule by what was the derivative inside. So now secant squared of x is now multiplied by 12 tan cubed of x. So then we get 12 secant squared of x tan cubed of x. And that's our derivative of 3 times tan to the power of 4x. Okay, let's try another one. This time, a little bit more to do. So we've got to apply the chain rule twice if we look carefully here. So we've got 3 times tan to the 4 of 3x. So we set it up 3 times tan to 3x to the power of 4. So you can see here the chain rule. We've got the tangent here, and we're also going to need to do it again for the 3x. So power rule first, 3 and the 4. So the first, as we did before, it's almost the same function as before, which is here, 3 tan of x to the power of 4. But this time the input is 3x. So applying the power rule first, so apply the power rule to tangent 3x, where 3 is the coefficient here, and to the power of 4. So we end up with 3 times 4 times tan 3x cubed, which then gives us 12 tan cubed 3x. Now we apply the chain rule to the tangent. So that's the first thing we do. So when you apply the chain rule, you work on the outside and then keep going in and in and in till you get to the last set of brackets. So we've got the tangent 3x is in one set of brackets and the 3x is in a set of brackets within that. So this is why we do the chain rule to the tangent first. So derivative of tangent is secant squared and the input never changes. So tangent 3x, the derivative of that before the chain rule is secant squared. So now we multiply secant squared by what we got to after the power rule. So the power rule gave us the 12 tan cubed 3x. So now we're going to multiply that by the secant squared 3x, which gives us 12 secant squared 3x tangent cubed 3x. But as we said before, we have to apply the chain rule to 3x. And again, don't change the input. So 3x, the derivative of 3x is 3. So now what we do is we multiply the whole thing here by 3. So 3 times 12 secant squared 3x tan cubed 3x, which then gives us our answer multiplied all together, 36 secant squared 3x tan cubed 3x. So there we go. So quite a lot of information there. Power rule first, apply the chain rule to the tangent, and then apply the chain rule to the input, which is 3x. So there you can see it. So there you can see when you see you've got a power. So there's the power rule first. Then if you write it like this, you'll see there's a chain rule to the tan 3x, and then chain rule again to the 3x. So that's that one. Okay, so now let's go on to exponential functions. So exponential functions involve using e. The e we know is 2.71 and so on and so on. But when taking derivatives, the e never seems to change. But all the stuff around it does change. So if you have e to the x, the derivative of that is always e to the x. But when in this one here, we've got e to the 2x, we have to work with this 2x a little bit. So the indice, when you use with when you're dealing with an exponential function, doesn't change. So it's a bit like the trigonometric function. The input there doesn't change. But what you do, you have to apply the 2x to the whole of the function. So we'll let g of x equal 2x, e to the 2x. Now the indice 2x will let be h of x. Okay, so the derivative of e is e to the x. We know that, so I've left that as e to the 2x because we're going to leave that input there. The derivative of 2x is 2. So basically what we're doing here, we're applying the chain rule. So e to the 2x, you apply the chain rule to the 2x, multiply it out by front, and then leave the input the same as the e to the 2x. So the derivative is h prime of x times g prime of x, which is 2 times g prime of x, which was e2 of x. So basically 2 times e2 of x, which gives us 2 times e to the 2x. And that's our derivative of exponential functions. Like that. That's a nice way to start. You can see you just take the derivative there and multiply it out front. So that's pretty straightforward. So now let's try another one now. This time I've got one with a coefficient. So coefficient, as with trigonometric functions, we work the same. The coefficient goes out front, stays there, and you multiply that up. The input or the indice will not change, that's 4x, so that stays at 4x. But you do have to apply the chain rule to it and multiply it out. So we set it up as 7 times e to the 4x, where 7 is a constant. So we leave that till the end. So we forget the 7 for now. So g of x equals e to the 4x. The indice is 4x. So h of x goes to g prime of x, which is e to the 4x, times the derivative of h of x, which is 4. So applying the chain rule to that 4x. That's what's going on here. So applying the chain rule to 4x, we get 7 times h prime of x times g prime of x. So h prime of x is 4, g prime of x is e to the 4x. So 7 times 4 times e to the 4x. 7 times 4 times e to the 4x is 28 times e to the 4x. So that's that one there. So you can see where that comes from there. 7 times 4 is 28, and then the 4x stays. So that's how we get to the 28 e to the 4x. Okay, let's try one now with a negative exponential. So again, as before, the 5 is a constant, so leave that till the end. And e to the 3x, e to the minus 3x, the minus 3x will stay because that's the input, but we have to use the chain rule to minus 3x. So I'll set it up like this again. 5 is a constant, leave to the end. Let g of x be e to the minus 3x, with the indice being minus 3x, which is h of x. So the derivative of e to the minus 3x will leave us e to the minus 3x for now, because that won't change, because the input won't change. But we do have some other stuff to apply. So the derivative of the input is minus 3. That's minus 3x. The derivative of that is minus 3. That's applying the chain rule to minus 3x. So now we end up with 5 times the derivative of h, which is the input, minus 3x, and the derivative of e to the minus 3x, which we left as e to the minus 3x. So 5 times minus 3 is minus 15, and then e to the minus 3x. So we end up with minus 15 e to the minus 3x. That's our derivative there. So you can see where that comes from. Minus 3 times 5 is minus 15. That goes out front, and the minus 3x stays. So that's our derivative there. So now we'll have a look now. We've got a negative coefficient and a negative exponent. So minus 8 times e to the minus x. So minus 8 is a constant. Leave that till the end. So g of x equals e to the minus x, where the indice is minus x. So we'll call that h of x for now. So the derivative of the e to the minus x will leave as it is, because that stays. Derivative of minus h of x, minus x, sorry, is minus 1. That's applying the chain rule to minus x. So minus 8 times the derivative of h times derivative of g is minus 8 times minus 1, which gives us plus 8. And the derivative of g of x, which stayed, was e to the minus x. So minus 8 times minus 1 is plus 8. So it's 8 to the power of minus x. So you can imagine here minus 1x. So minus 1 times minus 8 is plus 8. So 8 goes out front, and then the minus x doesn't change. So that takes care of exponentials. So now we're going to look at logarithmic functions, i.e. ln. So here we've got a function ln of 2x. Well, we know that ln of x is basically the reciprocal of the input of the logarithmic. So if it's ln of x, it's the reciprocal of x, which is 1 over x. So ln of 2x, we have to go 1 over 2x and then apply the chain rule to 2x. So our input for the logarithmic function is 2x. So we'll call that h of x. And the derivative of that is 2. So that's our setup. So we're going to apply the chain rule to the 2x. So derivative of our function ln of 2x will give us 1 over h of x. So that's that one there. So the 2x will stay, times the derivative of 2x. So we've got 1 over h of x times 2, which is 2 over 2x, which then we got the 2's can cancel out, which then gives us 1 over x. So funny enough, the logarithm of ln of 2x is still 1 over x, the same as it is for ln of x. So that's quite an interesting outcome there. Okay, now we've got one a little bit more complicated here now. So we've got 4 times the natural logarithm of 3x plus 1. So we're going to set that up 4 times, ln of 3x plus 1. So to set that up, we set 4 as a constant multiple, and then the input is the 3x plus 1. So we've got a little bit of chain rule to apply here. So the input is 3x plus 1, which we'll call h of x. And the derivative of 3x plus 1 is 3. So applying the chain rule to 3x plus 1, we've got 4 times 1 over h of x, so that's 4 times 1 over 3x plus 1, times the derivative of 3x plus 1. So that again gives us 4, which is our constant multiple, which we put out up front. So 4 over h of x times 3, which was the derivative of the input. So that then gives us 12 over h of x. So our derivative of 4 times ln of 3x plus 1 is 12 over 3x plus 1. So that's our outcome there. So basically what you could do is 4 times the derivative of here, which is 3, which is 12, and then 12 over 3x plus 1. That would be a shortcut, but that's how we get to that figure. Okay, so now we've got one now with a fraction, and also we've got a power in here. So quite a bit of work to do here. So half times ln of 3x squared plus 1. So our half is our constant multiple, so we leave that till the end. We use 3x squared plus 1 as our input and take the derivative of that when applying the chain rule. So here's we set it out here. So half is constant multiple, input 3x squared plus 1, h of x, which is 3x squared plus 1, the derivative of that is 6x. So derivative of 3x squared plus 1 is 3 times 2 is 6, that's applying the power rule. 2 reduced by 1 is 1, so 6 times x power 1 is just 6x. And the derivative of 1 is 0, because that's just a constant. So derivative of any constant is always 0. Okay, so now 3x squared plus 1 is our h of x, so that then goes on the denominator. So we've got a half times 1 over h of x times the derivative of h of x. So we can distribute the half, so there's our half, and there's our h of x. And then we put in our derivative there, which is 6x. So now we've got 6x over 2 times h of x, which then gives us 3x over 3x squared plus 1. And that's how we get to that derivative there. And you can see it's quite a lot of work to do there. Got a power rule, we have the chain rule, and we also have to take the derivative of the logarithmic function. Okay, so next one. So now we've got some complicated one now. So now we've got to take the derivative using the power rule, chain rule, and the sum rule. Okay, so having a look at this function here, we've got minus 4 times, in brackets, x to the power of 6 minus 3x cubed plus 2 to the power of 6. And that's quite a lot of things to do there. So let's break it up. So first of all, we take the minus 4 and bring that out to front and leave that till the end, that's fine. Then with the polynomial in the middle, we put in the brackets, which we can take the derivative separately using the power rule. And it also applies the sum rule because we've got a plus and minus, so we apply the sum rule to those. And it also got the power rule because everything's to the power of 6. So let's apply the power rule first. So we let g of x be our polynomial in the middle, and then a and b will be our minus 4 and our 6, as we did in the first page. So we've set that up there. So we now get to this bit now. So we do a times b times our polynomial, and then the b power is reduced by 1. So taking that, we do minus 4 times 6 times g of x, our function g, to the power of 6 minus 1, which is 5. So our first stage, when applying the power rule, we're left up with minus 24 times x to the power of 6 minus 3x cubed plus 2 to the power of 5. So you can see how we've got there. The 6 times the minus 4, minus 24, this stays, and that's reduced by 1. But now we've got to apply the chain rule to everything that's inside. The x to the power of 6 minus 3x cubed plus 2. And the derivative of that is just applying the power rule one more time. So x to the 6 is 6 times 1, which is 6, and reduce by 1. So that gives us 6x to the 5 minus 3x cubed. So we've got 3 times minus 3, which is minus 9. And then the x is reduced, the x power is reduced by 1, so that comes to 2. So minus 9x squared, which is there. And then the plus 2, so that's just a constant. So that derivative of that is 0. So nothing to write there for that one there. So what does that leave us with so far? So we've got the derivative of r inside times what we had before the first power rule, which is minus 24, and then something to the power of 5. So we have to multiply these all together. So we've got minus 24 times 6x to the 5 minus 9x squared times x to the 6 minus 3x cubed plus 2 to the power of 5, which we'll just write with normal brackets like that here. Okay, so what we can do now, we could simply leave it like that. To leave it like that is absolutely fine. But what you'll see with 6x to the 5 and minus 9x squared, we've got an x squared which we can take out of there and a 3. See, 6 will divide by 3 and so will minus 9. So if we take a 3 and if we take also out an x squared, so bring that to the front, so 3x squared. So 24 times 3x squared, minus 24, is minus 72x squared. And then take the 3x squared out of each of these. So 6x to the 5 divided by 3x squared is 2x cubed. And minus 9x squared divided by 3x squared is minus 3. So then it becomes minus 72x squared times 2x cubed minus 3, and then x to the 6 minus 3x cubed plus 2 to the power of 5. And it's always good because if you can reduce these powers here instead of this one here, you'll find it's probably sometimes easier to solve. So if you're looking for a solution, you might find it easier that way. Okay, so that's a power rule, chain rule, and sum rule. That's quite a complicated one. So let's try again with another one. So this time we've got 7 times 3x to the 4 minus 2x cubed minus 2x all to the power of minus 4. So if we want to set that up ready to apply the power rule, we'll leave this 7 out front and the minus 4 and leave this function in the middle. So I've set it up with nice square brackets so it's easy to distinguish. So using our power rule, where a is the 7 and b is the minus 4. Okay, so applying the power rule with our function inside, which we'll call g of x. So 3x to the 4 minus 2x cubed minus 2x, we'll just call g of x. So we've written that here. So now applying the power rule, a times b times g of x to the power of b minus 1. So as we did before, just leave it as g of x because it's easier to do there rather than keep writing this out inside. Just leave the g of x. So 7 times minus 4 times g of x to the power of minus 4 times to also minus 1. So minus 4 minus 1 is minus 5. 7 times minus 4 is minus 28. And it's times by g of x. So what we end up with now is minus 28 times 3x to the 4 minus 2x cubed minus 2x to the power of minus 5. So now we have to apply the chain rule to this stuff inside. So our function g of x, 3x to the 4 minus 2x cubed minus 2, the derivative of that is 3 times 4 is 12, and then reduce that by 1, that gives us 12x cubed. So there's our 12x cubed. 2x cubed, take the derivative of that, that's 3 times 2 is 6, 6x and squared. So that's the minus 6x squared. And minus 2x, derivative of that is just minus 2. So here we've got the power rule and the sum rule all together inside one little polynomial. So 12x cubed minus 6x squared minus 2 is our derivative of the g of x. So now we're going to have to multiply the derivative by what we had after the power rule, which is minus 28 polynomial to the minus 5. So the derivative that we just worked out for g will now be multiplied by minus 28 times 3 to the x to the 4 minus 2x cubed minus 2x to the power of minus 5. And that, all separated out, is quite easy to write because you've got the derivative there, so just bring that down and multiply it by the polynomial. So minus 28 times 12x cubed minus 6x squared minus 2 in brackets, open bracket again, 3x to the 4 minus 2x cubed minus 2x to the power of minus 5. And I've done separate brackets here so you can see where each term comes from. Hope you don't mind about that. Now I'm going to put everything into the same brackets. So minus 28 times 12x cubed minus 6x squared minus 2, and then 3x to the 4 minus 2x cubed minus 2x to the power of minus 5. Now there's stuff we can do here now. This minus 28 times 12x cubed minus 6x squared minus 2 doesn't have any power, so that will stay on the top. But this here, this last polynomial, 3x to the 4 minus 2x cubed minus 2x to the power of minus 5, because it's a minus 5, it's actually on the denominator. So we can write this like this. So we can write it as a quotient. Minus 28 times 12x cubed minus 6x squared minus 2 divided by 3x to the power of 4 minus 2x cubed minus 2x to the power of 5. And that gives us our answer. Okay, so that gives us our insight onto derivatives using the power rule, the chain rule and the sum rule, using trigonometric functions and logarithmic functions and polynomial functions. So hope you enjoyed, and the next video I'm going to make is going to be about product rule and quotient rule, which are essentially the same thing, but I'm going to show you how to do each one in separate steps. So look out for that video. There'll be a link below for that. So any questions, leave in the comment box below, and thanks for watching.